Hi, I'm Rody, a developer relations engineer on the solutions team at Google. Today, we are going over how to build a modern three-tier web application in the cloud. A multi-tier application is split up into multiple layers, such as presentation, application, and data storage. The productivity app we are building is a to-do list tracker deployed as a serverless container on Cloud Run, which is used to host the web server, a Golang-based API for the application, and a Postgres database cached with an in-memory store on Redis for data storage. This provides easy scaling to users all around the world and can handle spikes in traffic while increasing performance, reducing latency, and scaling to zero. The reason we use a three-tier application architecture is to allow for flexibility of frameworks and languages while also increasing the ease of deployment and compartmentalizing the scaling and responsibilities. The front-end layer is built using a Nginx web server, which serves simple HTML and JavaScript. The business logic is handled on the API application layer and will be built using Golang. And finally, the data storage layer is built on top of Cloud SQL using the Postgres database and has a caching layer built with memory store for Redis. To deploy the backend, we containerize the front-end and middleware layers deployed on Cloud Run, and they can connect to the data storage layer via the VPC or virtual private cloud network. Creating all the layers can get tedious and complex, and there are tools like Terraform which make it easier to declare the infrastructure as code and set up automated deployments. For content-driven applications that include frequent interactivity, there needs to be thought given on the type of data that needs to be stored and the frequency and throughput of the data accessed. Here, we're using a traditional relational database management system because of the benefit it provides, such as data integrity, consistency, transactions for ACID compliance, and powerful querying capabilities, and a well-defined schema. As an alternative, this could have been built using a NoSQL database, such as Firestore, because it makes scaling easy and has a flexible data structure that is great for prototyping. Thinking about our data and what will be most frequently accessed, we can add caching to improve performance by reducing round trips to the database. This example uses memory store for Redis and will have very low latency on data retrieval and will be even faster than local storage because it is all in memory. For the front end, we will use client-side rendering with minimal HTML and JavaScript interface to render the data provided by the API layer in the backend. When building the front end, inclusive and accessible web experiences need to be prioritized so that as many users around the world can access and use your application. Web frameworks can be helpful when building out interactivity on the client that follows the best practices and can also help make localization easier. For content-driven applications, performance is going to be critical for getting users to stay on the page and come back. Tools like Page Insights and Lighthouse can help you test your application in critical areas and can help benchmark against well-established metrics like the Core Web Vitals. All of the layers of the application are deployed as containers on Cloud Run, and we use this service because each of the layers can be deployed separately and can easily scale. It is also possible to scale the instances to zero, and so you're only billed for the request time. Cloud Run will handle the scaling for you. Incoming requests are handled by the front-end container, which is directly exposed to the internet via Cloud Run and serves the front-end files to the clients. Clients then access the API layer container as needed to retrieve and store the data. The to-do list application includes a lot of interactive elements, which make it unsuitable for SSG or static site generation. Since the application uses CSR or client-side rendering, we will need to deploy the route handlers that handle the incoming requests to the API layer, as the clients send requests to interact with the data in different ways. To take full advantage of this cloud-centric and serverless approach, we can further improve performance by caching the requests coming in by using a CDN, cloud storage, or Firebase hosting. The API layer is written in Golang and could be abstracted further with an API gateway management service like Apigee or API Gateway. This would give your API endpoint additional security, caching, monitoring, analytics, while making the API easier to manage. This is just a starting point for your application, and feel free to explore the example and make it your own. Thanks to the three-tier architecture, you can update the front-end, back-end, and data storage independently without affecting the rest of the system. Make sure to check the pathway linked in the description with all the links and a simple click to deploy on Google Cloud.